So we are discussing about the isomers here. For example, ma'am, I'm having like this. I'm having to orthonitrophenol. I have para-nitrophenol in this case. This nitrogen. This is the structure of NO2, isn't it? You can see the bonding is happening here. Because of this, this is steam volatile. But here, this will go with another species. This will go with another species bonding. So its boiling point would be higher here. So this is the general idea about the hydrogen bonding. Now, what is the strength of hydrogen bonding? Usually, the hydrogen bonding is very stronger. This is the order. You can see this hydrogen is bonded with a very electronegative element, and the same hydrogen is going bonding with another electronegative element. Again here, oxygen, hydrogen with oxygen. Nitrogen, hydrogen with nitrogen here. What are we trying to infer here? We are trying to infer how much electronegative is the element to which the hydrogen is bonded, how much lone pair to this element is having the another element which you are having right now, and how much electronegative it is also. That gives you the strength of the hydrogen bonding. Now in this case, I can see it is OH and this is NH. Here, this would go for an hydrogen bonding like this. But here, it would go for an hydrogen bonding like this. So this is weaker when I compare to this hydrogen bonding. That makes the water to boil at very high temperature. You can see the difference here. 100 degrees Celsius and minus 33 degrees Celsius. That's the strength of hydrogen bonding. Understood?
Yes.
Yes. Now we are moving for the basicity order of amines. Children, as I complete, I keep scrolling it, but if you want me to stop so that you can take the notes of it, you can tell me. Okay. We are discussing about the basicity order of the amines as we discussed it already. Look at this order here. I'm having ammonia. I'm having aniline here. Ma'am, this is NH2 and I'm having NH3. Here, this nitrogen has not got bonded with any kind of characteristic electron withdrawing group or electron donating group. We know very well hydrogen never comes into plot itself. But here I have benzene. When you compare the electronegativity difference between carbon and nitrogen, definitely there is a lot of electronegativity difference, isn't it? Also, we saw that this nitrogen is pushing this electron towards the benzene because of this sp2 hybridization, right? Because of plus M effect. So this lone pair is not available. So it is the least, followed by ammonia. Let's go for the next three combinations. What is this amine called as, Surya?
Yeah, benzylic amine.
Correct. It is called as benzanamine. The amine is called as benzanamine. Common name is benzylamine. Now, ma'am, here this NH2, is it aliphatic or aromatic? Dragishram,
Aliphatic.
is this aliphatic or aromatic? Dragishram?
Aromatic.
Why do you say it's aromatic? Da? Check where is this NH2 group attached. Is it directly attached to benzene or attached through CH2 here? Look at this NH2. Look at this NH2. What is the difference? The NH2 is directly attached to benzene, right? What about here? The NH2 is attached to a carbon which is attached with benzene. So this is aromatic amine and this is aliphatic amine. Understood? I can't regard it as an aromatic amine. Okay, pa? But still, ma'am, this NH2 is there. If I'm having carbon here, so there is a pull towards this benzene. So therefore, this has to be little bit less basic compared to ammonia. Let's compare RNH2 and R2NH. CH3NH2, and let me say I'm having, if they are not expressing what is this R properly, and they are not telling me what is this R properly, then always go for tertiary is greater than secondary, greater than primary due to plus A effect. Since they mentioned just R, I said is RNH2 is greater than less than R2NH because I'm having two plus A effects here. But if the questioner is asking with respect to the mediums in which the basicity is being discussed, from amine chapter, most of your questions is from qualitative analysis, distinction test, and it is from basicity order. This is the common questions we have for JEE. Okay, so if I'm talking about basicity of amines in gaseous medium, in other words, they are not expressing, they are not giving you, not given the medium. They are just asking you about the basicity. Just go for tertiary greater than secondary greater than primary. But if in case they gave it is aqueous medium, because I'm having RNH2 in the presence of water, H2O, right? This is a base. Here, water is going to act as an acid here. Like what? It will release its H plus. So that I have Rn plus H3 and OH minus. Amines in the presence of water, this acts as a base, this acts as an acid. It abstracts the proton so that it forms RNH3 plus and OH minus. You can understand there is a protonation effect is happening there. That means water molecules can come and surround this because I'm having a positive charge here. Can you see the positive charge here? The water molecule can come and surround it. So as the water molecules are coming and surrounding it, it finds its basicity obviously goes down because steric hindrance comes into factor here. So in the case of aqueous medium, you will not be following this order usually. You go to the another order here. If this is methyl, if the R group is methyl, then the order is secondary greater than primary greater than tertiary. Okay? If the R group is
How is
methyl,
that, ma'am?
see, I'm having a very methyl is very smaller when I compare to ethyl or propyl or butyl. So if this CH3 is a very small one, we will try to understand this with the help of inorganic chemistry concept. Wait. Your question is, give the trend in mobility of Be2 plus to Ba2 plus in aqueous solution. What is your order?
Ma'am, the smaller, whichever has smaller atomic mass will have like higher mobility.
Now you tell me here. I'm giving you a question here. Be2 plus, Ba2 plus.
Ma'am, first it will be Ba2 plus, then after that it goes on until Be2 plus.
So Be2 plus will be having less mobility or more mobility?
Less mobility.
Why?
Ma'am, because it's very small, and then a big water molecule over it,
Ah,
so
that's
so
it.
it'll have very less mobility.
That's it. So when I'm talking about Be2 plus and Ba2 plus here, remember the question is not about just Be and Ba. If it was, Ba will be very small, very least in its mobility. Because down the group I go, the size will increase. But in this case, I am comparing between Be2 plus and Ba2 plus. Ba2 plus is small. So as Surya says, so many water molecules will surround it. As so many water molecules are surrounding, it finds it very difficult to move. Movement becomes hindered. But in the case of Ba2 plus itself is so large. So water molecules is not providing that much kind of crowdedness in it. So that will move faster. Correct?
Yes, ma'am.
Yes. In this case, we are talking about the basicity of the amines. Here, steric hindrance also comes into play. Also, plus A effect also comes into play here. And I'm talking about plus A because basicity is directly proportional to plus A. Ma'am, when I am talking about plus A effect, then tertiary should be greater than secondary than primary, ma'am. Correct?
Yes, ma'am.
Yeah. But steric hindrance also comes into play. We are not talking about mobility, we are talking about the basicity here, right? Steric hindrance. What do you mean by steric hindrance? Ma'am, too much methyl is surrounded, ma'am. I'm having NH2, R is there. If something has to come and take it, it has to overcome all these R here. Then only it can come and take it. Am I right?
Yes, ma'am.
Yeah. So, with respect to methyl specifically, steric hindrance plays a vital role here because the plus I effect provided here is very less compared to ethyl or propyl. Both are giving their dominance, there is no doubt. But what's happening with respect to methyl, steric hindrance is playing a little bit over role compared to plus A because it's just only one CH3 group here. But when I say ethyl, it is CH3, CH2. When I say propyl, there are three carbons are there. Am I right? Okay,
Yes.
ma'am. So in that case also, ma'am, shouldn't be primary greater than secondary than tertiary? If the tertiary, steric hindrance is playing the role, tertiary is having much more steric hindrance definitely compared to secondary. There is no doubt. So experimentally, it is found that for methylamines, tertiary with respect to tertiary, steric hindrance is dominating. With respect to secondary and primary, plus A effect dominates the steric hindrance. Understood, Pa?
Yes, ma'am.
Right. Now, this is not the case if I am talking about ethylamines. With respect to ethylamine or more than that, when my R group is greater than ethyl or equal to ethyl. And in case secondary is greater than tertiary, greater than primary. This is the basicity order. Okay?
Ma'am, is there a case where tertiary is the greatest?
Tertiary can't be greater here. Steric hindrance will definitely play the role.
Okay, ma'am.
Now we are moving for the carbon nitrogen bond length order. Discussing on carbon nitrogen bond length order. Look at the molecules we are provided with.
Ma'am, how
Hmm.
do we like determine melting point, ma'am? Like boiling point, we are determining through like hydrogen bonding.
Melting point, you don't have a proper order, right? It's very irregular. But whenever you are having some symmetry is it that will be having the least melting point
Okay, ma'am.
because they have they don't have some regularity here. So whenever you are having symmetrical molecules, they'll be having the highest melting point, and that you could have seen with your molecules that is provided. Like for example, if I am having this molecule, comparing with this, This is quite symmetrical. It goes and sits in the crystal lattice very properly. So it will have the highest melting point.
Okay.
Let's
And
go
so
for the
other than that, there's no other rules.
sorry, ma?
So other than this, there's no other.
No, no,
Yeah.
no,
Okay.
no. They generally ask you for boiling point. They don't ask you for melting point order. Only one place that they ask you for the melting point order is with respect to symmetry and close packing.
Okay,
We
ma'am.
would have discussed with this hydrocarbon chapter. When it's becoming tertiary, they are having higher melting point. When it is tertiary, there will be low boiling point. We would have seen it, no? I'm having R, which is going to be primary here. Primary is greater than secondary in tertiary boiling point order. Because this is having a higher possibility of doing this hydrogen bonding. One point if there is OH, if only just an hydrocarbon is provided, because of more surface area, primary will be having the higher boiling point. When you compare the same pentane molecule or hexane molecule, when it is in the primary position, secondary way, tertiary way. We're talking about tertiary, symmetric is there and is getting more spherical. Because of that, we say it is having the lowest boiling point.
Okay, ma'am.
Okay. We are
So
moving for
more
the
branched means like less boiling point.
exactly that's it. Branch means less boiling point. Symmetry it's with respect to how symmetric melting point is with respect to how symmetrically it is being placed.
Yes, ma'am. Got it.
Now we are moving to the carbon nitrogen bond length. As we know very well, Sp is least molar compared to Sp2 compared to Sp3. The more is the percentage of P, the more will be the bond length. Because P orbitals are generally longitudinal, they are away. Compared to S, they are away from the nucleus. So more is the P, the more will be the bond length. So we are having an order when there is also resonance is involved in it. Right? Sp3 will be greater than Sp2, greater than Sp, no doubts about it. But with respect to resonance, more resonance is available with them, then definitely they are going to be shorter. They come close with each other. They create an intermediate partial double bond they are making, right? So more resonance compared to less resonance here. Let us look at the molecule. Here, the nitrogen is with sp3 hybridization. It is also bonded with sp3 hybridized carbon, piperidine molecule. So there is no possibility of resonance, nothing is there. So it is having the highest bond length, no doubt. Look at the last molecule, hydrocyanic acid. Here, nitrogen you can see it is present in the triple bond, sp hybridization. Correct? So therefore, it should have the least bond length. Now comes the intermediate. Look at the next compound. Here the nitrogen itself is bonded in the double bond. Am I right? So what is
Yes, ma'am.
hybridization here? 1, 2,
Sp2.
3. So sp2 hybridization. Remember, we will include lone pairs for hybridization, but not the pi bonds. When you count the hybridization, include the lone pairs, but not the pi bond. Here also same thing. 1, 2. So only we said it is sp hybridization. So we discussed, okay, sp3 is over, sp2 is over, sp is over. What next? In all these cases, the nitrogen is bonded with sp2 hybridization only. But it is not exactly sp2. Remember, children, look at this case here. Here, nitrogen itself is bonded is sp2 hybridized. But in this case, is nitrogen sp2 hybridized? No. sp3 hybridized. Here, sp3 hybridized. Here, sp3 hybridized. But what has happened? It has got bonded with sp2 hybridization. Can I say the difference here? Here the nitrogen is sp2. Here the nitrogen is sp. Here the nitrogen is sp3. In all these cases also nitrogen is sp3 only. There is no doubt. But where have they got bonded to? They have bonded to the carbon which is sp2 hybridized. So definitely you can't go and compare with the real sp2 hybridized nitrogen. No way. The real sp2 hybridized nitrogen will be having the least bond length compared to these three cases. Asini, is that clear till this?
Yes, ma'am.
Okay, then what are the other cases? But why did you keep it less than sp3? Here also nitrogen is sp3. Here also sp3 is hydrogen. But why did you put it less carbon nitrogen bond length? Because these nitrogens lone pair is going to get involved in the resonance. So let me consider this molecule at first. What kind of a group is aldehyde? CHO? Electron withdrawing group, stronger pulling effect. So eventually, even if I'm having just aniline also, nitrogen will push its electron towards benzene. There is no doubt. There will be a formation of partial double bond character. Correct? There will be a partial double bond character would have got formed. There is no doubt. But here, it's not just because of benzene alone. Even aldehyde is there. So it is like acting like a very super magnet. Even though the lone pair is definitely going to come to benzene only, but because of this aldehyde, what happens? Still more, it is pulling this lone pair very close to it. Won't that make the bond length still more shorter?
Yes, ma'am.
Yeah, everyone. Okay, let's compare between them. Ma'am, here also it's benzene, ma'am. It is going to come, ma'am. But there is no electron withdrawing group. Let us compare between this and this. Ma'am, here also nitrogen is there, ma'am. Lone pair, it has to come to benzene. But benzene is already overcrowded with plus I groups, which themselves are providing benzene with the electron density. So won't there be electron-electron repulsion? Gragishram, do you understand?
Yes, ma'am.
I'm having this methyl is there, and already the benzene is having three plus I groups. So already benzene is enjoying the electron from these three methyl groups. Then this electron which is coming here is not that much essential for the benzene. That doesn't mean benzene will not say you don't come. It has to come only. That is the reason we say its bond length is less than this. Clear na? Is it clear for this question? The question is very repeated C and bond length question. Hope you people understood why do we follow this order here. Any doubts with this? Any doubts, Pa? Yeah, I'm asking you only, da.
No doubts, ma'am.
Okay. That's fine. So I'm having alcohol. I treat it with ammonia in the presence of alumina. What is alumina? Dehydrating agent. So I can understand I should remove water. Yes. So OH from here and hydrogen from here. So I form RNH2. So this is RNH2. To this, to this, I'm adding ROH. We're adding ROH to it. So what is this reaction called as? Typically an ammonolysis type of a reaction, isn't it? Having RNH2. To this I'm having ROH. Correct?
Ma'am, it's like that
Ah,
Halfman elimination kind of thing.
Elimination will form alkene, right?
Yes, ma'am. But here also like where this exhaust to methylation or something like that.
Yeah, exhaustive methylation is happening. Yes. You can see the R group is again increasing it to R2NH. One more ROH I'm adding it. It is becoming R3N. In Hoffman ammonolysis, we are increasing the N groups there. Here we are increasing the methyl group. So as Surya is correctly identifying, this is a type of exhaustive methylations. So this is very common for JEE, giving you the compound, asking you to find the number of isomers. So the first one you can see is a primary amine. The second one we can see is secondary. The third one is tertiary. Looking at the nomenclature, I have told you, use the longest chain to mention the amine. To this nitrogen, methyl is attached. So, which what it has got with N. So it's N methyl, ethyl amine. Two CH3s are there. And here it is tertiary amine here. So it's a trimethyl amine. Whichever pathway I take, I can take only one. So I'm taking like this. To this N, two methyl groups are added. So I'll say N comma N, dimethyl methylamine. Okay. Yes, student.
Yes, ma'am.
Right. Let's go for the next one. I want to convert this alcohol into amine, adding one CH2 group to this. They are giving you a pathway as well. They are asking you to find out which one should be the reagent here. OH is getting converted to Cl. Anything you should use, you can use. I can use HX as well. I can use PCl3 as well. I can use PCl5 as well. But among them, the most best method is using thionyl chloride. So I'm using thionyl chloride. You can see the Cl is getting converted into Cn. You should use KCN. Instead, the choice will also give you AgCN. If you do that, you will form RNC, isonitrite. So you should not use this. I use KCN. Now you can see the Cn is getting reduced to form CH2NH2. So use just in reducing agent. Could be just a lithium aluminum hydride. Could be sodium in the presence of ethanol. Is this a reducing agent?
Yes, ma'am.
Yes. Why? How can we be
Ma'am,
sure this
because
is the
it's like
reducing? Ah,
it'll form like C2H5O minus Na plus, and then
ah.
H will be added.
Sodium is an active metal, not just sodium, any active metal in the presence of alcohol, in the presence of acid, even in the presence of base. They will be releasing hydrogen gas. Okay, so as Surya is saying, 2 moles of Na could have given you 2 Na plus 2 electron. This ethanol would have given you H plus, right? Which is 2 moles as 2 H plus it will give you. So 2 H plus 2 electron is nothing but hydrogen gas. Addition of hydrogen is reduction. Okay, Pop?
Yes, ma'am.
Next one, aldehyde in the presence of hydroxylamine. What will you do? Remove water or CH4, NH2, OH. Remove water so that you are forming RCH double bond NOH. What is this compound called as? Oxime. The moment I say oxime, what rearrangement you should remember?
Beckman.
Beckman rearrangement. Very good. So remember Beckman rearrangement here. So oxime upon reduction. Remember please, oxime upon reduction will form amines again. Very simple, break the bond. Reduction means addition of hydrogen, removal of oxygen, right? So I'm adding just hydrogen here and I'm removing oxygen. So I'm forming amine. Okay. I'm having RC double bond O. I'm treating with some reagent to form this. What should be the reagent, Hasini?
NH2OH.
Correct. I'm using NH2OH. What is the name of this reagent? What is the name of this reagent?
Hydroxylamine.
Hydroxylamine. To this, I'm adding some B to form this amine. Raksham, what should be the reagent? Ragishram, are you there? We are waiting for your answer. Make it fast. What reagent will you use? Now only we learned, what reagent will you use? You're reducing it. What did you do here? Which reagent you used? We'll use a common reducing agent like lithium aluminum hydride or hydrogen in the presence of nickel to convert the oxime into amines here. Right?
Yes, ma'am.
Next one. We are converting acetamide to ethylamine. What is acetamide? Anything which is attached to this acetyl group is called as acetamide, right? This is acetamide. So you can see I'm converting it into ethylamine. That means I'm removing this oxygen, instead I'm having hydrogen. It should be a common reducing agent. Remember, sodium borohydride will not do this. NaBH4 will not do it. Lithium aluminum hydride is an unselective reducing agent. So it will reduce the carbonyl which is present in any groups. But sodium borohydride is very specific, selective reagent. Yes? Okay, da?
Yes, ma'am.
Right. Did we solve Hoffman bromamide reaction already in your class?
Yes, ma'am. We did it in carboxylic acid lesson, I think.
Oh, okay. We are converting acetamide to methylamine here. In the previous case, you converted acetamide to ethylamine. That means you retained the carbon. In this case, you are removing this carbon itself. So the very best process for us is Hoffman bromamide. I use bromine in the presence of 4 moles of potassium hydroxide, where this CO can be released so that it becomes CH3NH2. You have to remember the mole ratio of the bromine and potassium hydroxide. Recently, this is the part of questions that we expect, that we are seeing in JEE of late, that they ask you for the ratio of the reagents. Yes. The next question. They're asking you to find what is some X which is getting formed. This X upon treatment with Y on treatment CaO in the presence of lime gives you Z, right? Which is having a vapor density of 30. I'm recording my sessions here. Vapor density into 2 will give you the molecular mass. Always try to remember this benzene molar mass is 78. Keep it in your mind. So at the moment I see 39, I can understand the compound Z is benzene. Okay. Some Y upon treatment with calcium oxide in the presence of lime. So what is this reagent? This is nothing but soda lime.
Decarboxylation.
Very good. We know very well when I'm having this RCOH in the presence of soda lime, this undergoes decarboxylation. That means you'll remove carbon dioxide from it so that you'll form benzene. So I understand the compound is going to be, the final compound is benzene. That means this compound is having carboxylic acid. Okay, how many moles of carboxylic acid? That you can't decide now. You have to go for the reaction here. I can see this compound is having a fish order here. Okay, fish order it is having. Amines generally are having a little bit of fish order. Isonitrile will be having foul smell. Amines has fish order. Okay, so from where it would have started, the reaction is Gabriel phthalimide. We practiced it already in our class in the last session. I use a base here, which is going to abstract this, right? So that it becomes N minus. Now this is a SN2 reaction, very important children. SN2 reaction. So only you say you can't prepare aromatic amines because you can't do SN2 on sp2. No SN2 on sp2, right? So what is happening? This is N minus, the X minus goes so that it becomes R. Now I again go for base hydrolysis where I cleave it so that it is forming 2 moles of carboxylic acid I'm getting. What is this? This is phthalic acid. Correct? So which upon treatment with soda lime would give you benzene. The next question is about isonitrile here. Isonitrile upon something is giving you RNHCS3. Understood RCN upon reaction with lithium aluminum hydride will give you RCH2NH2. If I take isonitrile, same thing only you should do no. Break the bonds, introduce hydrogens in between. Correct, Appa? So I will have
Yes, ma'am.
R with nitrogen, I add one H, and with C goes H3. So is this a secondary amine? So we can remember isonitriles. Isonitriles upon reduction will give secondary amines. Let's go for the next. Same thing again. What is the name of this compound? Registrar?
Compound, no?
This compound. This one. What is the name of this compound? Mm. Louder, please. Cyclo. How many carbons it is having? Then what should be the name? You are very close. You said cyclopentanone, but how many carbons it is having? 6 carbons, na? So what will be the name? Cyclo?
Cyclohexanol.
Cyclohexanone.
Pentanol.
Huh?
Oh,
Hexanone, ra. 6
hexanol.
carbons are there, na?
Hexanol.
To this, I am adding hydroxylamine. As usual, remove water so that I form an oxime here. To this, we are treating with a reducing agent, sodium in the presence of ethanol. What will it give? It will give cyclohexanalamine, right? Okay, now the question is for Surya. Surya, I am having this compound. I am treating it with concentrated sulfuric acid in the presence of heat. What will be a product?
Ma'am, it'll be a sound member ring, ma'am.
Okay, very good.
Then there'll be like a ma'am, I can't name the compound, but
You have a common name for this compound, na?
like NH over here, double bond like next to the NH,
Hmm.
double bond over next to the NH.
Okay.
I can't name it, ma'am.
What is this rearrangement?
Rearrangement is Beckman, ma'am.
Beckmann rearrangement, right?
Yes, ma'am.
Asini, what is this compound, ra? Is it caprolactam? You have discussed it as caprolactam, isn't it? The one which is used in the synthesis of nylon 6. Please mention it in your classwork. Forms caprolactam, which is used in the formation of nylon 6, not nylon 6, 6. Nylon 6, 6 monomers are different. This is nylon 6. எவ்வளோ பூ வீணா போயிருக்கோம் லோக்கி, எவ்வளோ பூ, 25 பூ போச்சு லோக்கி இந்த மாதிரி.
Ma'am, then what does a nylon 6,6 look like, ma'am?
Nylon 6,6 is made with adipic acid and hexamethylamine. The 6 years tells you about the number of carbon that is present here. Adipic acid also has 6 carbon. Hexamethylamine is also having 6 carbon. Here I am having just 6 carbons. Only one monomer for me. It is a homopolymer. Okay. This is a heteropolymer. Okay. Let's go for the next reaction. Reductive amination. Whenever I'm having aldehyde, I treat it with ammonia or any amine followed by reducing agent. We will form the reductive amine. That means RCH4 will react with ammonia at first. Will form RCH double bond NH. What is this compound called as? C double bond N. What will you call this? Is this called as imine?
Oxime.
Right. Oxime is C double bond, NOH is oxime.
Oh,
C
okay.
double bond
Yes, ma'am.
NH will be called as imine.
Yes, ma'am. Yes, ma'am.
Okay. So this upon reduction, I'm using hydrogen in the presence of nickel. No? So what will you get? I'll just break the bond, add two hydrogens both the sides. This forms imine.
Ma'am, which forms remain, ma'am? I didn't see it properly.
C double bond NH. This compound is called imine. You formed
No,
this
I'm like,
imine
what
by
form?
reacting with aldehyde, ammonia, or even amine. Anything could react. So you treat
Okay, ma'am.
aldehyde with ammonia, remove water. Okay. You have a special reducing agent for imine. Yeah, imine can be reduced even by hydrogen and nickel, nothing wrong in it. But if you want to selectively target only imine, the selective reducing agent is NaBH3CN.
Ma'am, what does NaBH3CN reduce, ma'am?
It reduces imine. For example, you had this RCH double bond NH, na? You have to convert it into amine, na? Like this.
Okay, ma'am. So only that, ma'am.
Only
Except
that.
that,
Ah,
nothing.
yes. Because if that compound is also having a double bond and you don't want to touch that double bond, you can't use hydrogen and nickel. Hydrogen and nickel will go and reduce the double bond also.
Ma'am, can LiLH4 also do this, ma'am?
Yeah, it can also do it.
Okay, ma'am.
I'm talking about specific reagent. Just like diborane, we learned that carboxylic acid converting into alcohol. We have a specific reagent, diborane. Same way, this is a specific reagent.
Ma'am, what about
Hmm.
like NaC2H5OH? That will also reduce this.
Yeah, they will all reduce. I'm talking about specific reducing. All general reducing agents will reduce. What are they actually reducing? Just breaking the double bonds here. That's it.
Yes, ma'am. Yes,
Anything
ma'am.
that can supply hydrogen can reduce the. We are talking about specific reagent. I want to touch only the C double bond NH, ma'am. In that case, what reagent will I use? You will use NaBH3CN.
Sorry, ma'am. I got confused by like seeing double bond over there, and then
Ah,
I thought
okay.
it won't reduce.
No Okay, next one. I'm having propanol. You can say I'm reducing it into secondary amine here. So I understand that I have to use CCCH double bond. What to this? If I use it, won't I create this compound?
Yes, ma'am.
Let's go for a statement-based question now. There is a compound X which reacts with KCN to form Y. So I understand yes, Br has got replaced by Cn, nucleophilic substitution. So that nitrogen is there, and you can see there is an increase in carbon number. From C7 it made to C8. Reduction of Y with lithium aluminum hydride gives Z. Because I know what has got formed here is cyanide only. Cyanide upon reduction lithium aluminum hydride will what will happen? Won't it reduce increase the hydrogen count there? It will become CH2 NH2, isn't it?
Yes, ma'am.
Yeah. So that means I'm adding four hydrogens to it. You can see from seven hydrogen it became 11 hydrogens. Z gives carbylamine reaction and reacts with Innsbruck reagent as well in the presence of aqueous KOH to give a clear solution. We are going to learn about the qualitative analysis test for amines now. A very major common reaction is called as carbylamine. Okay. Show you the carbylamine test, please wait. Surya, unmute. Surya, mute yourself.
The Excel, I can help you wherever you think that I can be of help to you. Give me a taste. Physics, chemistry, maths,